Greetings, science fam. We are going into the introduction of radioactivity, something that a lot of people have an opinion about but don't often know a lot about. So let's break it down from a chemistry point of view and looking at that energy in that. So here we go. First thing is that radioactivity has a really simple definition. If there's energy coming from the nucleus, when that nucleus breaks down, we call that radioactivity. So the idea that when a nucleus breaks down, it's giving off energy, we call that radioactivity. Now, that's the act of giving off energy, but that specific energy itself, we call radiation. All right, so a radioactive material gives off energy, and that energy we call radiation. Now, notice I didn't say whether it was dangerous or not. Not all radiation is dangerous, and we'll get into that. When an object naturally breaks down, though, we call that element a radioisotope. So for some reason, just sitting out in the open, it just naturally breaks down. Its nucleus breaks apart into other elements. We call that a radioisotope. And the process of that radioisotope breaking down is called radioactive decay. Remember, when something like that happens, you form a completely new nucleus, so a completely new element is formed. So this isn't really a chemical change, where you're like combining elements to make a new compound. We're talking about a completely new element being formed. And this spontaneously happens, meaning it naturally happens. So when an object breaks down, a radioisotope goes through nuclear decay, it can give off a couple different things. One thing it can give off is an alpha particle. An alpha particle actually is just the nucleus of a helium. So its mass number is 4 and its number of protons is 2. When alpha particles come off of an object, they shoot off when a radioisotope goes through decay. The good news is, though, that an alpha particle is easily stopped by a piece of paper, clothing. It doesn't really have much penetrating power. So overall, alpha particles are pretty weak. By the way, we note alpha particles with the Greek symbol alpha when we talk about them. So you can either write it as a helium nucleus or as 4/2 alpha. Another type of particle given off during decay is like an electron. We call it a beta particle, and the symbol for it is a beta symbol, which just looks like a bee with a little tail on it. All right? Since it's the same as an electron, another way we can write it is with an E for electron. But its symbol is 0/-1. Just remember it is 0 having no mass, and -1, well, just think of it as like electrons have a -1 charge. That's not actually what it stands for, but for what we're learning right now, it's an easy way to remember it. But beta particles are 0/-1. Beta particles are stronger than alpha particles. All right, so these are ones that you have to be more careful with. They can pass through your skin, but thick layers of clothing can stop it. But beta particles definitely have more energy than alpha. Another type of object or thing that's given off during decay can be gamma rays. Now, gamma rays are not particles, they're actually waves, and they pass right through you. In fact, they have very high penetrating power, go right through you, and just thick sheets of lead stop it. Gamma rays are given off when suns are, dying and exploding in supernovas. Stars give them off. And then also there's gamma radiation given off, like when an atomic bomb goes off in fission or at a nuclear reactor. But the symbol for it, notice, is 0/0 because there's no mass to it, no protons. And that symbol is gamma, a Greek symbol. It kind of looks like a fancy Y. But when we put them in order, alpha's the weakest, beta or the electron is next, and then gamma is the strongest. One other that I want to talk about that we don't cover too much is a positron. A positron is basically the size of an electron, but it has a positive charge. So sometimes there's this little positive particle that's given off during decay, meaning when that radioisotope breaks down and it shoots off these positrons. This is something that's really unstable, doesn't last very long, and breaks down. But it is something I just wanted to introduce to you quickly, that positrons exist, and sometimes we'll need it to kind of balance out our nuclear equations. All right, so besides decay, which is breaking down, sometimes we can start a decay in the lab by doing what's called nuclear bombardment. If If you ever played dodgeball, another name for dodgeball is bombardment, basically where you're getting hit with a ball to be put out of the game. Well, we can take a particle and hit its nucleus in order to create a change. So since we're hitting it, we call it bombardment. With nuclear bombardment, this is where some powerful things can happen, and that's actually how we take fission. Remember, we take that uranium-235 element and we take one neutron and slam it into the uranium-235, which eventually creates fission. So starting fission is actually a nuclear bombardment. So the two things we talked about were nuclear decay, the breaking down, and the nuclear bombardment where we actually hit another element. When we use bombardment, we can hit it with some different things. We have different things that naturally break down, so we can shoot alpha particles at an element. We can shoot beta particles like electrons at an element, or we can shoot neutrons. Neutrons are the easiest because they don't have a positive or negative charge. Remember, alpha particles are positive charge, beta particles are negative, but neutrons are neutral charge, so that's easier to hit the nucleus with. But just so you know, there are different things we can use to hit other elements. Now, the reason we talked about that is, remember, radiation, radioactivity, is just that energy given off when an object, its nucleus, is breaking down. We'll get into more about like what's dangerous and what's not, but remember, alpha particles can be stopped by your clothing, beta particles can be stopped by thick layers of clothing or like wood or something like that, and then gamma radiation is different. That's tough to stop. You need like thick lead. But we can start looking at these different nuclear equations to explain nuclear decay and bombardment. So if you take a look, first of all, uranium-238 over 92, and then there's an arrow. You can treat the arrow like an equal sign, meaning that we're going to compare this side and then all of this side of the reaction. All right? So if we look, that equal sign, if you look at 238, the mass number on top, 4 plus 234 equals 238. Notice that the top numbers will always equal. So will the bottom numbers. 92 is on this side of the equal sign, so 2 plus 90 is 92. So you'll notice in nuclear equations that they'll always balance out. In fact, aluminum 27 plus 4, all right, 27 plus 4 is 31. On the other side of the arrow, which is like an equal sign, is 30 plus 1. So 31 is both on top for both sides of the arrow. 13 plus 2 is 15. 15 plus 0 is 15. So the bottom number as well is equal. So if we look at these types of reactions, we'll see if you start with one element and then there's an arrow and it breaks into two pieces, we're going to call that decay because it started as a whole and it broke into pieces. All right? But if we look at this top one again, that is also a decay. You start with one thing and then the arrow breaks into two pieces. The second one, though, if you look, the arrow's right here. Two things hit. It's aluminum 27, and then this is an alpha particle, 4 over 2 He, if you remember the symbol for it. Now, since they're adding together before the arrow, that means like they are colliding with each other, and that's called a bombardment. So this one is actually a bombardment. And since it's hit with an alpha particle, we would actually call it alpha bombardment. This one that's a decay, if you look 0 over negative 1e, that's a beta decay because it gave off a beta particle and broke down. So we're going to work on balancing these nuclear equations to get a better idea of what goes on in the world of radiation. Remember, radiation is just that energy being given off when the nucleus breaks down. So we got from there. At least it's a good start, Science fam. Thanks for sticking with it. Best of luck.